Hey, Functions and Trig, how's it going? Hope you're doing well. And looking forward to staying at home until at least May 1st, because that's what we're doing. So just found that out today. Very exciting. No, I'd much rather be at school. Anyways, we're going to take a look at a few of these problems here. I'm not going to work the problem out for you because these are all like one-of-a-kind problems, but I am going to give you some hints or suggestions about things that you could do to kind of get started on it, right? If you're having trouble with that. So let's take a look at the first one here. Problem number 1. Did I number them as like, yeah. Problem number 1. The local grocery store sells leaf bags in 2 different sizes. Cylindrical bags so cylindrical, shaped like cans, like cylinders, have a base radius of 6 inches, are 4 feet high, and sell for $4.99 per 5-pack. So that's basically $1 per bag. Spherical bags, so spheres, like it's a ball shape, have a radius of 18 inches and sell for $4.99 for a 3-pack. If your goal is to maximize the volume of leaves you can store in the cheapest way, which bags should you buy? Which is essentially like a complicated way of asking, what's the better deal? So you basically got to figure out which bag deal gives you the most volume for the least amount of money. So just to let you know here, I'll go over here and switch over to my... All right. Cylinder. Is it cylinder? I hope it is, because I just wrote that down. Did I spell that? I am like, I'll tell you what, I'm the worst speller ever. The way I can typically tell if I've misspelled a word is by going to Google and searching it, and if I see it comes up, cylinder, I did spell it correctly. Otherwise, it would say, did you mean? It would correct my spelling for me. So, okay, volume of a cylinder is, okay, volume equals, that's essentially base, area of base, times height. And for most, like a lot of 3D shapes, that's basically what the volume formula is. It's whatever the area of the base is times the height. In this case, the base, right, is a, right, it's the worst looking, it's a circle on the base, right? So it would be pi r squared times height. Right? Squared, of course, means that you multiply, the r is the radius, which I think we were told is 16 inches or something like that. So squared means you multiply it by itself, then you multiply it times pi, then you multiply it times the height of the cylinder, which I forget what that was, right? And then, of course, you got like multiple bags in a package for that. And I forget what the price was, right? So, but you got to figure out your total volume that you're getting for that price, and then you can divide volume divided by price will give you volume per dollar. Okay? So you can find out what's my volume per dollar. Then you go to the sphere. Right now I have sphere volume. Okay? That is S, right? S for sphere, whatever, equals 4/3 pi r cubed, not squared this time, cubed. And that means that you multiply the radius times itself, but we multiply 3 of them all together. Or your calculator probably has a button that looks kind of like that, right, for cubed. And you just put to the 3rd power, like whatever your radius is to the 3rd power. Or you just take the radius that you're given and like multiply 3 of them together. That's to the 3rd power. So you'll take your radius, multiply 3 of them together, then times pi, then times 4/3, and that will give you the volume of a sphere. Those are the sphere-shaped bags. Now, of course, you get several of those in a package. I forget how many, but figure out how many you're getting in that package, and then you'll have the price for that total overall volume, and you can go volume divided by the price will give you volume per dollar. So the amount of like bag volume you're getting per dollar. Of course, whichever one's the better deal, I suppose, would be the one that gives you more volume per dollar. Yeah. All right, so there you go. That's problem number 1.